So in this video we are going to discuss what single phase half wave controlled rectifier with RL load. So in the previous video we have discussed the R load. Now here it is resistor as well as the inductor. If you see the simple diagram, what will the change will happen? Only thing is that input is basically Vs we are giving, right? One thyristor is there, control switch we are taking, and R load will be there. Along with that L also will be there. That's only the difference. So this particular thing is the load V out, voltage across the load V out. Then thyristor, this is Vs, which is Vm sin omega t, sinusoidal waveform. So the input is basically the sinusoidal waveform you can observe over here, right? Then triggering we are giving in the waveform you can observe. Triggering for the thyristor. Thyristor is there, that's why we have to give the triggering. Output voltage, we have to focus on the output voltage. Now here, whenever inductor comes, the new term will come, which is nothing but beta. So if you observe beta, beta is basically what? Beta is the extinction angle. The theory part we are not going to focus, we are just focusing on what the derivation of the two important things. One is the average output voltage and RMS output voltage. Okay, so based on the output voltage waveform we have to calculate. So let us focus on that, starting with the first term. So average output voltage, so what you have to consider, we'll start with the V out average, which is equal to 1 by the time period into 0 to t V out, which is a function of omega t into d omega t. Okay, so let us focus on the time period. Now if you observe the time period, which is basically from 0 to 2 pi we can consider. Okay, but the problem here is that where it is conducting, the thyristor is not conducting from 0 to alpha. Alpha to pi, it is same as the V input. If you observe, it is same as the V input, right? Now next thing, because of the inductor, the beta angle, because of the inductor again it will conduct from what? Pi to beta. It will follow the same thing. So alpha to beta, the thyristor is conducting. After that it has stopped conducting till 2 pi. Again it will follow the same waveform. That means where it is stopping and again following, the periodic angle will be, periodic pulse will be from 0 to 2 pi. Okay, after that it follows the same thing. Okay, so wherever it follows the same thing you have to stop there. So it is from 0 to, it is the time period will be 0 to 2 pi. Okay, so 0 to 2 pi if we consider also, we cannot directly write, because we have to break it. 0 to 2 pi can be broken into three parts here. One is 0 to alpha, another one is alpha to pi, another one is pi to beta, another one is beta to 2 pi. Okay, either looking. So we cannot directly write this part. See, 0 to 2 pi has to be break down into how many parts? 4 parts. 0 to alpha, alpha to pi, pi to beta, and beta to 2 pi. Okay, so let us see that. So I am breaking this up. One is 0 to alpha, then alpha to pi, then pi to beta, then beta to 2 pi. That completes the entire periodic pulse. Okay, now here 0 to alpha not conducting, 0, output voltage will be 0. Pi to alpha it is conducting, okay, it is same as Vs, and pi to beta also it is conducting, it is same as Vs. Beta to 2 pi it is not conducting. So only part you can see is that alpha to beta, this particular part, it is same as the input waveform, correct? If you see, it is same as the input waveform. So only thing is that the periodic cycle we are going to take is from alpha to beta, directly from alpha to beta. Don't need to break into two parts, directly from alpha to beta. So this will change into, rest all things 0, that's why we are not taking. Okay, so 0 to, sorry, it will be from alpha to beta. Okay. Now V out, what is V out? It will be same as Vs. What is Vs? Vm sin omega t. So directly put Vm sin omega t d omega t. Now again the same thing. V out average is equal to, so what will happen? 1 by 2 pi. Now integrate, the Vm is constant, take it outside. Integration of sine is what? Minus cos. So minus cos omega t, and limits is from alpha to beta. So upper limit minus lower limit you have to put. So Vm by 2 pi, upper limit will be what? Minus cos beta in place of omega t. It is with respect to omega t. Minus of minus. See, remember here minus sign is there. When you put the lower limit, minus of minus, it will become plus cos alpha. Okay. So this you can rearrange. So the V out average will be, the final term you can write it as Vm by 2 pi cos alpha minus cos beta. Now where alpha is the firing angle for the thyristor and beta is the extinction angle when there is an involvement of what? Inductor. That you will be learning in the theory part. Okay. This is the average output voltage. Next we'll go for the second part, which is the average output current. Average output current is simple. What you have to do? So I out average is equal to, I is equal to V by R, right? So it is same as V out average divided by R. So what is V out average? Vm by 2 pi. I can put here R into cos alpha minus cos beta. That's it. RMS output voltage. RMS output voltage is simple when you get the average output voltage. This particular function, right? This particular function you have to take the square root, and inside the function, inside the integral, whatever the function is there, they square it. Individually you square it. That's it. So what will happen? V out RMS is equal to square root of 1 by 2 pi. Integration was from alpha to beta Vm sin omega t. So you have to square Vm square sin square omega t d omega t. This we have done in R load also. Same thing. As I said, it is the same procedure. Okay, only the limits will change. That's it. Periodic angle will, periodic cycle will change. Now, since this is a square root, it will get complicated. I am going to shift the square root towards the left side. It will become V out RMS square for the simplification purpose. Otherwise, you can take it square root itself, or otherwise you can take it as square root as half, power half. That is also fine. Now here 1 by 2 pi is Vm square is constant. Vm square you can take it outside. By 2 pi is there. Now integration of sine square omega t, we don't have direct formula. What we are going to use is that we have studied the formula of cos 2 theta, which is equal to 1 minus 2 sine square theta. Now I need sine square theta, so I am going to shift this side and this side. So what will happen? Sine square theta is equal to 1 minus cos 2 theta by 2. This formula we are going to apply. In place of theta, I am having what? Omega t. So it will become integration of alpha to beta. I am just simplifying the term. I am not applying the integration. Okay. So it will become 1 minus cos 2 omega t. In place of theta, omega t. Okay. Divided by whole divided by 2 d omega t. Okay. So this 2 you can take it outside since it is a constant. So what will happen? Vm square by 4 pi it will become. Now 1 integration with respect to omega t will be omega t minus cos to omega t integration sine to omega t, constant is there, by 2, upper limit minus lower limit, sorry, upper limit and lower limit both you have to put. So V out RMS square Vm square by 4 pi. So upper limit will be what? In place of omega t you have to put beta. So beta minus sine 2 beta by 2 minus lower limit you have to put in place of omega t alpha. Alpha minus sine 2 alpha by 2. Okay. Simplification. So V out RMS square is equal to Vm square by 4 pi This one beta minus alpha you can consider together. Then what is left out? Minus sine 2 beta by 2 plus sine 2 alpha by 2. Okay. Now next. Now V out RMS I need. So square I can take it that side. So Vm square will become what? Vm, because I am taking the square root. 4 square root is what? 2. And pi square root pi I'll take it inside. That is better. Or otherwise if you want you can write root pi. Square root of beta minus alpha minus sine 2 beta by 2 plus sine 2 alpha by 2. So this will be the final thing. So if you want you can take this particular root pi inside also. So it will become Vm by 2 pi, sorry 2, only just a 2 it will be there, right? 2. Inside the bracket it will become what? Beta by pi minus alpha by pi and minus sine 2 alpha 2 beta by 2 pi plus sine 2 alpha by 2 pi. So this will be the final thing. So V out RMS is equal to this particular function, this particular expression. Now the last and final thing, it's the RMS output current. So how to calculate? Same thing, same logic. I out of RMS is equal to V out RMS by R, V by R, right?